So in the last class, we have studied about the effect of water table on bearing capacity. So we see that if the water table is at a equal or greater depth of df plus b, that is the depth of the foundation, and plus the width of the foundation from the ground surface, then there is no effect of water table on the bearing capacity of the shallow foundation. Okay, and if it is in between the depth of the foundation and from the ground surface, then it's affect the bearing capacity of the soil. So we have seen that there are some equations that there are some formula that is used to find out the effect of the water table on the bearing capacity. So we see that we already taught you that there is a two method to find out the effect of water table on the bearing capacity. The method first is the reduction factor method, where we introduce two reduction factor Rw1 and Rw2, and Qu is given as the ultimate bearing capacity CNC plus gamma df and Q Rw1 plus half gamma E and gamma Rw2, where Rw1 and Rw2 is the Rw1 is the reduction factor for water table above the base level of the foundation. Rw2 is the reduction factor for water table below the base level of the foundation. And gamma, here gamma is the gamma saturated for all practical purposes in the both the second and third term of the this equation. For finding Rw1, we know the formula, that is Rw1 is equal to half 1 plus dw1 by df, where dw1 is the depth of the water table from the ground surface to the water table, and Rw2, that is in the case 1 when the groundwater table is between the depth of the foundation and the ground surface, that's mean dw1 by df is less than equal to 1, and in that case Rw2 that is equal to 1. And in the second case, when the water table is below the base of the footing and at the depth of df plus b, in that case Rw1 and Rw2 is given by half 1 plus dw2 by b. Clear? And another method, that is the equivalent effective unit weight method. In that case, Qu is given as CNC plus gamma E1 df and Q plus half gamma E2 P and gamma, where gamma E1 is the weighted effective unit weight of soil lying above the base level of the foundation, and gamma E2 is the weighted effective unit weight of soil lying within the depth B below the base level of the foundation, where gamma M is the moist or saturated unit weight of the soil lying above water table. Okay, and gamma saturated is the saturated unit weight of soil below the water table. Gamma B is the submerged unit weight of soil, that is given as gamma saturated minus gamma W. Again, we see that there is a two case 1 and case 2. That is, the case 1 is that when the water table is in between the ground surface, this one, and the ground surface, this one, and this base of the footing. In that case, the gamma E1 is given as gamma B plus dw1 by df into gamma M minus gamma B, and gamma E2 is given as a gamma B. And the case 2, when the water table is here in between the depth of base of the footing to the df plus B distance from the ground surface, or B distance from the base of the footing. In that case, dw2 is the distance from the base of the footing to the water table, and in that case gamma E1 is given as gamma M. Here this one, the gamma E1 is given as the gamma M. Gamma M is the moist or saturated unit weight above the water table, and gamma E2 is given as gamma B plus dw2 by B into gamma M minus gamma B. Okay, so already we have seen these things in the last class. Now we have to solve some problems on the basis of these equations. How can we find out the ultimate bearing capacity or net bearing capacity or net allowable bearing capacity, we will see in the some examples, some problems. Okay, so let us start the first problem. That is, have you seen this problem? सभी को दिख रहा है?
Yes, sir.
Okay, so let us start. A strip footing of width 3 meter is founded at a depth of 2 meter below the ground surface in a C5 soil, having a cohesion C is equal to 30 kN per meter square and angle of shearing resistance phi is equal to 35 degree. The water table is at a depth of 5 meter below the ground level. The moist weight of the soil above the water table is 17.25 kilonewton per meter square. Determine A, the ultimate bearing capacity of the soil, B, the net bearing capacity, and C, the net allowable bearing pressure, and load per unit meter for a factor of safety of 3. Use the general shear failure theory of Terzaghi. Okay, so this is the problem. Now we have to solve this problem. So first of all, we will see what are givens. So here a strip footing of width 3 meter. So the width of the footing is given 3 meter and the footing is a strip footing. So you can see it in this figure. This is a strip footing of width 3 meter. It is also given that at a depth of 2 meter below the ground surface in a C5 soil having a cohesion C is 30 kN per meter square and angle of shearing resistance is phi is equal to 35 degree. So it is given that the depth of the foundation is 2 meter and phi, that is the angle of internal friction, is given 35 degree. Gamma, that is the unit weight of the soil, that is 17.25 kN per meter cube, and C, that is the cohesion, is given as 30 kN per meter square. As it is given, it is a C5 soil, so C is also given and phi is also given. Clear? Gamma is also given. Now further, it is stated in the question that the water table is at a depth of 5 meter below ground level. The moist weight of the soil above the water table is 17.25 kilonewton per meter cube. So the water table is given at a depth of 5 meter from the ground surface. So this is the ground surface. So the depth of this is the water table level, and this water table level is at a distance of 5 meter from the ground. So you can see that the width of the foundation is 3 meter and the depth of the foundation is 2 meter. So the total is df plus b, that is the 2 plus 3, that is the 5 meter. So the groundwater table is at a distance of 5 meter from the ground surface. It means that it is at a distance of df plus b, and we know that if the groundwater table is at a depth of df plus b, that is or greater than df plus b, then there will be no effect of water table on the bearing capacity. So this water table has no effect on the bearing capacity. So just we have to find out the ultimate bearing capacity without considering any water effect. Now again, the unit weight of the soil above the water table is already given 17.25 kilonewton per meter cube. Now the first is to determine the ultimate bearing capacity of the soil, second to determine the net bearing capacity, and see the allowable bearing pressure and the load per meter for a factor of safety of 3. And it is also given that to use the general shear failure theory of Terzaghi. It is already given to use the general shear failure theory of Terzaghi. So now we have to solve it. First of all, we have to find out the ultimate bearing capacity factors. Here you can see that there is no, it is not given the what are the values of NC, NQ, and gamma, but generally it will be given. So here we will find the for phi is equal to 35 degree, NC that will be the 57.8, NQ will be the 41.4, and gamma is 42.4. We can find this by the chart or by the graph that is already we have discussed in the previous classes. Now the QU, the first thing is that we have to find out the ultimate bearing capacity. So the ultimate bearing capacity QU is given as CNC plus gamma DF NQ plus half gamma B and gamma. So here C is given, that is 30 into NC, we already find out here 57.8 plus gamma, it is given 17.25 into 2, that is the depth of the foundation, NQ that is given 41.4 plus half gamma, that is again 17.25 into width, that is given as 3 into n gamma, that is 42.4. So by calculating this all, we will get the value of QU is equal to 4259, 4259 kilonewton per meter square. Now it is the first part A. Now the B is given that we have to find out the net ultimate bearing capacity. So the net ultimate bearing capacity is given as ultimate bearing capacity minus the overburden pressure, that is given as gamma DF. So 4259, that is QU, already we have find out, minus gamma, that is 17.25 into 2, that is again by calculating we will get the value 4225 kilonewton per meter square. So we will get the net ultimate bearing capacity. Now the next we have to also find out the C part. If you see in the C part, the net allowable bearing pressure and the load per unit meter for a factor of safety of 3. So net allowable bearing pressure, as per the definition, it is given as the net ultimate bearing capacity divided by the factor of safety. So already factor of safety is given 3. So net allowable bearing pressure is 4225 divided by 3, that is the 1402 kilonewton per meter square. So net allowable bearing pressure is 1402 kilonewton per meter square. And it is also asked that what is the load per unit meter. So it is the pressure. It is the pressure, that is the load per unit area. Now we have to find out what is the load per unit meter. To find out the load per unit meter, actually it is the 1408 by L into B. But we have to find out what is the load per unit length. So already length is not given, but the width is given. So QA is given as net ultimate allowable bearing pressure into B. So it is 1408 into 3. The width of the foundation is given 3. So that is 4,225 kilonewton per meter. So in this way, we have find all the asked parameters like ultimate bearing capacity of the soil, net bearing capacity of the soil, net allowable bearing pressure, and load per unit meter. Okay. So in this way, we have solved these questions. Anyone have any doubt?
No, sir.
कुछ
No, sir.
तो